Hi friends, welcome to our channel. In this video, we are going to look at problem 2661. First, completely painted row or column. So here our main purpose is to demonstrate to you the use of dictionary. So here I'm going to use Python. So the use of a dictionary. So this, if you practice quite a lot, you will find that when you do dynamic programming or do such problem here, so using dictionary is a lot of convenience, a lot of fun. So here we are given an array and given a matrix. So this array and the matrix actually contains same set of numbers. So the thing is that we want to go through each index I in the array, starting from the left, and paint the cell in matrix containing the integer array I. So we want to return the smallest index I or the earliest index, at which either a row or a column will be completely painted in the matrix. So if you look at example 1 to quickly gain the intuition. So you have 4 numbers, right? So the first one is 1. 1 is in the first row, first column, so you painted it. And then you have 3. 3 is in the second row, second column, then you paint it. And then if you look at index 3, which has a 4 in the array, so it will be painting the first row, second column. This is actually very special because when you paint this one, both the first row and the second column are painted. However, the problem requires us to return the earliest index in the array. So here the index is 2, so that's what we return. So similarly, you can look at example 2. So example 2, actually, according to the demonstration, so the index is 3. So basically, when you paint 4, right, then the second column first painted in full, right? So we are not going to go over in detail the constraints because there are some consistency ones like this one. And this one determines the problem size, right? So with that said, I guess the problem logic is rather straightforward. So here the thing is how to implement it with some efficiency. So here for pedagogical purpose, we are not going to give the shortest code, but we want to demonstrate to you the thought process with clean code. First, I'm going to get the number of rows and number of columns in the matrix. So that's very routine, right? Next, we are going to use 2 dictionaries to monitor the process. So we want to count how many positions are already painted in each row and how many positions are already painted in each column in the process. Because anyway, we need to iterate through this array or scan and stop at the earliest index. So here what I'm going to do is I'm going to have a row map. So this is the collections default dict. So in order to avoid using key check, because if a key not in the dictionary key set yet, you need to do check. But we are going to use default dictionary. So this brings us convenience. So I'm going to map everything to be 0, right? And similarly for column, I'm also going to do this. Default dict. So lambda also map everything to be 0. So this 2 matrix, so row map is going to monitor, so going to contain this kind of information, contains, so for each row, so let's say R row, so how many positions are already painted, right? So we want this count, thus a row has a count equals n, right? So it means fully painted. So similarly, you can consider a column map, right? It considers C and count. So if the count is M, so it means that a row is fully painted. So also I want to have another map. So another map is the integer to position, right? Because we need to quickly check if we look at this position, oh, this is the 1, integer 1, we need to quickly know its position. This is the 1, 1. This can be done just by scanning the matrix. Let me do this for I in range M. So for J in range M, right? So what we want to do is integer to position. So the integer will be matrix at this position. So we are going to map it to ig, right? So in other words, this will be an integer, let's say call it k, right? Map to the corresponding position. So the criterion is this. Matrix ig equals k, right? Let's use this. So that's this done. Then a natural question is how to check or monitor when a row or column is printed first. So we are going to use two running variable, counting variable called row max, and so it's equals 0, and column max, so equals 0. So these two variables going to, for example, row max going to see the row corresponding to have maximum positions already printed, right? For example, when you do here, so the row, first row, it has 1 printed, the second row has 0, right? So if you do see here, so you see the second row, first row and the second row both have 1. And then you do this one, first row have 2, so has 2, so it's fully printed. So that's the row of the two running variable. So now what we want to do, let's iterate over the array. So we know the array must have length m by n, right? So first we can get the position for this integer. So this, I'm going to use the integer to position, right? So here, this is the array I. So by checking this index, we get the integer. Then using this map, we get the position. So now what do we do? So because current row is R, current column is C. So the row map of C is incremented by 1, right? And so now I want to also check this variable. So if, so the row map R, not C. If row map R is greater than the current row max, so I'm going to set the row max to be the row max row map at R, right? So that's one. So similarly, you need to do column map at this column. So there's one more cell is printed. Similarly, if column map at the current column is greater than column max, so I'm going to set column max to be the column map at this key. So now we are going to check if row max equals n or column max equals c, right? Then we just return this I, right? So we don't care if the row max first arrives at n or column max first arrive at m, right? Because we only care about the earliest I, right? So it's possible, like in example 1. So if you print one integer, so both the corresponding row and column are fully printed at the same time, but that's no problem. So with that said, I guess that's the full code for this. Let's do a check. Yeah, it passes all the test cases here. Now let's look at the generic case. Yeah, it passes all the cases. So I guess for this problem, I guess the major thing is that you get this map, and then you do using some map to do the monitoring. So that's basically about it. Thank you for watching.